Welcome to this basic example section where we'll be learning the simplest Terraform case possible, a provider and a single resource. The provider is used to connect into whichever cloud provider it is that we choose to use, in this case AWS, and the resource will describe a single thing that we want to spin up in that cloud provider. Unlike the previous section where I was just demonstrating roughly what you could expect from Terraform and didn't expect you to actually do anything, in this chapter I would recommend you follow along, creating the code that I create for yourself and running it on your machine. As always, I'll be using our trusty Ubuntu 18.04 desktop running in a VirtualBox VM. If you haven't already created a GitHub account, or an account with one of their many competitors at least, I recommend you pop over and do so now. And also, create and clone a repository called Terraform, as we're going to be adding code to it as of now. All the code I create in these courses I'm going to be adding to my own repository just like yours, and you're welcome to clone anything I do from Lernard on GitHub. The link to this can also be found at the bottom of this video player. Right, as I've already created my Terraform repository in the last section, I'm going to cd into it here. You can see at the moment it only contains the folder from the last section, section 2, so I'm going to create a new one called section 3. Now, let's open that folder in Visual Studio Code so we can start creating some files in it. As I did in the last section, I'm going to create a file called main.tf. But now I'm also going to create a separate file called provider.tf. In the last section I just dumped everything into the main.tf file, but Terraform has a wonderful feature whereby you can actually make as many files as you want in a folder as long as they've got the .tf file extension, and when you run Terraform it just combines them all in memory into a single file to run. This is super handy as it allows you to logically split files based on their purpose, which starts to be really useful once things start getting more complicated, as you'll see later on. Right, as mentioned in the intro to this section, the provider is the bit that connects to the cloud. In our case, I'll be connecting it to AWS. So let's go ahead and write that now. First, write the word provider, because that's the component. Then specify AWS in quotes. Then create a pair of curly brackets for us to put our options in. This is roughly how most blocks of Terraform code look. The component type, a name, and then some curly brackets to put options in. Nice and simple. At this point for our provider, we're only going to put one option in, the region, and we'll specify US East 1. There are other options that can go in here, such as hard-coded credentials, and it's worth knowing that the Terraform website has excellent documentation for all the resource types for AWS, detailing what options you can include. Now, let's jump to our main.tf file. I've named it main.tf because this is a commonly used name, but as discussed in the intro, what we're actually going to put in here is a resource. There's almost as many different resources as there are things you can do with AWS, and the list keeps growing all the time. It includes everything from firewalls to databases to storage and, like we're going to use here, instances. As before, let's write the word resource as that's the component we want, then the name of the resource, which in this case is AWS instance, and now an extra field here, which is our own personal identifier for this, which I'm going to call section 3. As you can imagine, in big Terraform deployments there will be a lot more than just one instance being spun up. So this name is how Terraform will distinguish this from other instances, and we'll be going into that in more detail in a later section in this chapter. Let's make a pair of curly brackets again, and now we can populate this with some options. Again, there is a list of what options we could feasibly put in here on the Terraform website, but for now we don't need to check that as I'm going to do a pretty simple case. Firstly, we're going to need an AMI, which stands for Amazon Machine Image, and is the unique identifier for the operating system we want to use with the machine. You may remember in the video on the homepage of this website, and also in the Terraform introduction, that when I draw the Terraform stack, I include Terraform twice, and the word provision twice, once for the operating system, and once for the server itself. Well, this is why. When we're spinning up our instance here, we are creating both an actual server along with its accompanying RAM and CPU settings, and also specifying the operating system that will run on it using an AMI. I'll leave this blank for a moment while we fill out the rest of the resource and we'll come back to it. The instance type is an Amazon name for how powerful we want the instance to be. there is a huge range of different prices, billed by the hour for each different instance type. You can see here in an example I've pulled from the web the pricing for the T2 type instance, which is a good low-cost general-purpose instance type. In your life as a professional DevOps engineer, what kind of instance you pick might be quite important, as if you work for a government, bank or other large institution, you might be spinning up machines that total millions of pounds a month. But for our case, we can just go for a nice cheap one that will bill us almost nothing, or at least only a few pence for the amount of time we use it. I'm going to use the T2 Micro here, which is a good general purpose go-to. Next, let's specify a count, which is simply the amount of virtual machine instances we want. As we only want one, we actually don't have to specify this, but I think it's good practice to always be explicit about this, for reasons that will become clear later in the chapter when we start using reusable modules. Lastly, let's give the machine a name that will appear in AWS. AWS keeps the name of machines in a general purpose labeling function it has called a tag. To declare the tags for this machine, we need to open up another set of curly brackets, as we could feasibly have multiple tags. And now I'm going to write the name. Now, for the name to actually work, I would need to use a capital N, but I've deliberately chosen to write this with a lowercase n here. It won't throw an error, but it also won't actually put a name on the machine. I've done this to demonstrate the power of Terraform to fix faults and make changes to an estate, as you'll see shortly. Right, I'll call this section 3. Before we can run Terraform, just a quick reminder here that in the last section you may have noticed me using AWS CLI to configure my AWS credentials. If you personally haven't done this yet, it might be worth hopping back to the last section quickly and following through those steps. In general, I wasn't expecting you to copy what I was up to in that section, but you will need a working set of credentials for Terraform to function now. Once you're done, you should have a credentials file in your .aws folder in Home, as I do here. Finally, we need to go and get that AMI for the operating system we want to use, as we left that blank earlier. So, open up a browser, browse to the AWS console, and once it's loaded, there we go, click on EC2. Click on the Launch Instance button here, and it's now giving us the list of operating systems we can choose from. And you notice it's also giving us the AMI of each one here. In our case, we're planning to use Ubuntu, so let's search for that at the top. And here now you can see Ubuntu Server 1804, and next to it the AMI that we want to use. I'll just copy that here. And now we can switch back to our code and paste that in. Now you'd be right if you were a bit suspicious of what I just did there as not being very automated, particularly for someone that just spent 10 minutes jumping up and down ranting about the best practices of DevOps at the start of this chapter. And you'd be bang on if you were suspicious, because this is not a very good way to get the AMI. In reality, we could make a data block to search for this by name automatically, using wildcards where necessary, like you can see in this caption I stole from the Terraform documentation. But we don't need that for this example, and I think it just muddies the waters of illustrating the resource and the provider and how they work together. Later, in the section on data blocks, we will use this for sure though. Okay, we're good to take this for a test drive, I reckon. Let's switch to the terminal here, and we're going to use in turn our 4 golden commands of Terraform: init, plan, apply, destroy. Terraform has a whole lot of commands, all of which are probably very useful, but it's these 4 that you'll be typing again and again during your job. If you were preparing food, you might very occasionally use a fish descaler, but it's going to be the knife and fork you want 99 times out of 100, and so it is with init, plan, apply and destroy. You could only know these 4 commands and you'd be fine for most actual DevOps jobs. You can always pick up the extras as you go along. Anyway, that all being said, let's switch to the terminal, confirm we're in the section 3 folder, and now we can type terraform init. What it's doing here is downloading the AWS plugins required to work with the AWS API. Now it's done that, if we have a look back in the folder again, you can see it's created this .terraform directory. This directory is where it stores those plugins it's downloaded, and also any modules it gets in the more complex setups we'll be covering later in this chapter. You can delete this folder without causing much harm, and it'll just recreate it again next time you init. You can also type init as much as you want and it won't cause any harm. If the folder's already there, it will just overwrite it with identical files again to no harm. If you forget to write init, Terraform will fail on plan or apply, unless init had been run at an earlier date, so you have to run it at some point before you can do the others. Now let's move on to our Terraform plan. As I mentioned in the last section, this is a dry run to see what Terraform would do if we ran it for real. You want to do this every single time before you run and apply. The potential for damage of a dodgy Terraform config is enormous, and if someone accidentally deletes a whole web estate in production, they would be enormously fired. So it's always worth running a plan to make sure all is well. I really do this all the time in my job before I run Terraform apply. We can see here it's saying 1 to add, 0 to change, and 0 to destroy. So we're good to go ahead and write Terraform apply now. Yep, still looks good. So let's say yes to that and wait for it to run through. Great, it's done. Let's go and check it out in the console. Good, it's saying 1 instance running there, and sure enough, we can see it running in the console. If we select it and go and have a look at the tags, you can see that at the moment, name is still in lowercase, and in the column marked name, there is currently no entry on the machine itself. That, of course, is because we deliberately left name lowercase to simulate a mistake like this that we might want to change. Now, we could just change that in the console here, but as we discussed, that would not be very DevOpsy. Instead, let's switch back to our code and make the change here. Right, if I now run Terraform again and then wait for it to go through, there we go. It's now saying 1 changed. A change is something that Terraform can alter without destroying the resource. If I change something a bit more major, it might need to actually delete the virtual machine and recreate it, in which case it would then say 1 to create and 1 to destroy. But in this case, it's made the change on the fly without destroying the machine. If we go back to the console and refresh, you can see now that the name has appeared in the console because Terraform has made that correction. I really wanted to do this as an illustration of what I was saying earlier, because at the risk of sounding like some kind of lifestyle guru, DevOps is not just a tool set, but a mindset. A good DevOps engineer is always thinking about version control, automation, and idempotency. Manually changing the server is none of those things, and it will inevitably mean having to repeat the same fix multiple times when it reoccurs. Right, we're done with this example, I think, and we want to get rid of all the stuff we've created with Terraform. So let's use Terraform destroy so it stops costing us any more money. There we go. It's saying 1 to destroy, as we'd hope. Let's quickly hop into the console just to show that yes, it has really destroyed it. Now we've done that, if we take a quick look here in the section 3 folder, you'll see there's 2 new files there, terraform.tfstate and terraform.tfstate.backup. These 2 files are fundamental to how Terraform works. When a plan or an apply is run, Terraform doesn't actually go and scan the whole of AWS to see what you've got in there. All it actually does is check what it has put in there from the past, using a record it created itself when it made those very things. This is the reason that manually created things will not be affected by Terraform runs. Terraform only knows about what Terraform itself has created about, and it knows because it keeps a record in a tfstate file of what it last did. If we have a look here in that tfstate file, there isn't a whole lot in it, just a version in a serial really. That's because the most recent act we did was to destroy everything. There's nothing in here because there's nothing in AWS. That brings us to the tfstate.backup, which was what we previously had before our last action. If we take a look in that file, you can see now that it's got a whole load of machine details in it for the instance we span up, and it's used those details to know what it was it had to destroy. We'll be looking at this in even more detail in the section on backends, but for now, just being aware of it is enough. Right, that's it for this section. We've learned how to create a provider to link us to AWS, and then we've spun up a virtual machine instance using a resource. All that remains is to behave like DevOps professionals and commit our code to GitHub. Let's CD back to the root of the repo so we can easily see what we've made. Now, as we'll always be doing, let's git status to see our changes, then git add all, git commit and a sensible message, and then git push to master. Lastly, just to mention once more that all the code I'm creating in these courses is available free to clone at the Lernard GitHub account, and the link is at the bottom of these courses on the player. So if you'd rather cut and paste things instead of typing by hand, do feel free to do so. Alright, good job. Now let's move on to the next section where we're going to introduce variables.